Welcome to this channel, Chemistry Made Easy by Dr. Ashok Mulik. Today we will see the atomic structure in continuation of this topic, that is atomic structure. We will see today the angular functions and radial functions. Last time we have seen the various quantum numbers, that is principal quantum number, azimuthal or angular momentum quantum number, then magnetic quantum number and spin quantum numbers. And today we will see the angular functions and radial functions. In order to understand the role of these functions, we have to make use of this equation. We have to solve this equation so that we will obtain the value of this psi in terms of radial coordinates and angular coordinates. So in order to have the solutions, we should know about the atomic orbital. This is the structure or figure shows this diagram in which we are representing the atomic orbital in this circular form. So figure shows definition of polar coordinates. Here the figure shows definition of polar coordinates. So polar coordinates are defined in terms of their units, that is radians, and the here R. This R is shown here. R is radial coordinate. That is the radius at which the electron or the point is located. So this is the distance. R is the distance from the origin. This is the origin of the nucleus, and this is the point that is the place of electron, and it has coordinates r, theta and phi. So here this r is the distance from nucleus to the electron. Then this theta and phi are angular coordinates. So these points are described here. This point defined as the phi is equal to 0 radians. So this point gives us the phi value having 0 radians. So this is placed on x-axis. So this is away from the nucleus. Similarly, we have another point on z-axis. That is point defined as theta, and this is having value 0 radians. Similarly, we have showed here phi and theta, the angles, bond angles, or you can say the angles. So this theta is measured here using this along this arc. So there, that is the distance from this point to this point. So that is the arc. So this theta is measured along this arc, and this phi is measured along this arc. Phi is measured along this arc. So in this way, this gives us the diagram in which we can understand how are these positions occupied by the electron. Means we are considering this position, that is point at which electron is located, and this is the diagram for considering the atomic orbital. So after this, we see that the Cartesian coordinates and the angular coordinates are available. So this will define the positions of electrons. So this psi value describes about the wave function of that particular electron. So this will in terms of radians, psi in terms of radial and angular functions also describe the distance at which the electron is placed, or the point occupied by the electron is described by r, theta and phi. So this radial function is described by the quantum numbers. This radial function is described by quantum numbers ml and L. These quantum numbers, that is L and ML, will describe this radial function. Whereas angular functions are described by the principal quantum number n and L. So these will be describing the angular functions and these will be describing the radial functions. So this will help us to understand the point at which this electron is placed. They will also help us to understand the shape of the atomic orbital and its orientation in the space. So they will describe about the shape of the atomic orbital and their orientation in space. Similarly, the angular coordinates will also help us to consider about the probability of finding the electron in the space, that is in the atom. So we understand from this, the solution of this equation will help us to understand that as we move away from this nucleus, that is center of the atomic orbital, so the probability of finding an electron decreases as we move away from this nucleus or origin point. So if we consider the electron is present here, the probability of finding an electron is more. But if we go away from the nucleus, the probability of finding that electron becomes less and less. So the angular functions determine the probability changes. So angular functions show that the probability of finding the electron changes from point to point. So here the angular functions are explained by or determined by, so we will see here that the angular functions are explained by this. Angular functions are explained by here L and M, ML, and whereas radial functions are explained by NL and L. So we say that the probability of finding an electron also changes from point to point. If we move away from the nucleus, the probability of finding the electron goes on changing. So these angular quantum numbers will help us to understand the atomic orbital, shape of the atomic orbital and their orientation in the space around the nucleus. So these functions r, theta and phi will are determined by these quantum number values. Similarly, the radial function is described by this r. Radial function is described by this r. So that is the distance of the electron from the nucleus. So this value is also, these are determined on the basis of this N and L values. So these functions, that is the radial probability function, is described by or it is given by 4 pi r square 4 pi r square. So it describes the probability of finding an electron in the space around the nucleus at a given point in the space. So this electron density or probability of finding the electron falls rapidly as we move away from the nucleus. So with this we will stop here and we will continue the next point of this. In continuation of this, we will continue the other next point, that is nodal surface in various atomic orbitals in the next lecture. So we will stop here and we will continue it in the next lecture. Till then, goodbye. See you next time. Please subscribe to this channel. and share the channel with your friends. Please press bell icon button and like button, and you can share your comments in the comment box. Thank you very much.